Good afternoon, everyone, and welcome to the penultimate session of the day. We have Mr. Richard Taylor doing our presentation. Might I remind you of a few things? If you have questions, please put them in the green Slack channel. Also, too, if you have not done so already, please visit the sponsors. They help make all of this happen, and without them, we really couldn't do it. Without further ado, I'll turn over to Richard.
Can you guys hear me okay? All right, awesome. Thanks for that wonderful introduction, and thank you all for joining me this afternoon in this session on unit testing. And last but not least, thank you organizers for actually having me here at Star Trek. So this is pretty awesome. Just a little bit about myself. I'm a software engineer. Full stack software engineer is just a fancy word for I pretty much do all of it, front end, back end, database, you know it. I'm from Huntersville, North Carolina, which is actually right outside of Charlotte. And I'm pretty involved in the community. I work with our local Xamarin group, and I also work with a group called Modern Dev Charlotte, which is basically a technology agnostic group. We kind of focus on all the pieces and parts that come together to build enterprise applications. So that's sort of the focus there. I blog, that's my website, and I tweet quite a bit at Write and Code. Currently, I am the Director of Engineering for a company called SentryOne. We're based in Huntersville, North Carolina at the moment. And our software package is designed for database professionals and help them monitor, optimize, and performance tune their databases. So we do have developer tools as well if you want to performance tune your queries. So check us out if you're interested. Not to reiterate, but I just wanted to put the slide up here. So I guess our Slack channel is green. So please, if you have any questions along the way, go ahead and ask your questions there. So typically I ask the room, what's the experience around unit testing or with unit testing? But since this is sort of a unique venue, I'm not going to do that today. But I'm going to make some assumptions that some are familiar with unit testing, some are not. But I'll make sure that there's enough information covered so that we don't leave anybody behind. So the goals of this talk, basically wanted to take a quick moment to define unit testing. And then we're going to explore several styles of unit test. Then we'll move into identifying weaknesses in unit testing or unit tests. And then how do we increase the value of our unit test, which is basically the meat of this talk. So what is unit testing? Well, unit testing is a process of independently testing the smallest testable part of your code, a unit of work, for proper function. And typically it could be at a class level if you're going to actually test its public interface, or you can zero in on a specific method. And when you're talking in test terms, typically you hear something called SUT, which is basically system under test. So you'll hear me say that along the way. One thing to remember is a unit test is code. So it's actually code written to test code. Okay. And while unit testing can be done manually, it's mostly automated. That's where you get all of the value. And typically it's part of either your local build on your development machine or a part of a larger CI/CD or continuous integration, continuous deployment pipeline. Unit testing should be isolated. Testing more complicated scenarios is the responsibility of integration testing. So if you're building tests and it involves things like making network calls, making database calls, things like that, calls to other systems. That's not technically a unit test. That's more of an integration test, and those should be actually in their own category. And we'll talk about why that is a little later. One other thing we need to remember is that unit testing is not test-driven development, but is a component of it. So test-driven development, the concept at its highest level is you write your test, you watch them fail, and then you write your features to make your test pass. So unit testing is a part of it, but it's definitely not test-driven development. So why do we write unit tests? Well, for me, the number one reason is to increase confidence that code changes do not break existing functionality. So Being a developer, I work on a lot of different code bases, and I move from code base to code base. And it might be, extended period of time between looking at a code base and then actually revisiting it. So if, I get into refactoring, unit tests will help me at least make sure that I'm not breaking what I was actually intending the code to do. This also works well when you have new developers joining your team. It gives them a little confidence that, hey, they can actually get some work done and actually not tear up things, basically. To find errors early. Obviously, the sooner we find errors, whether it's as an individual developer or as part of a larger team, the sooner we locate them and actually identify them, the cheaper it is to fix, right? So if your test actually gets all the way to users, which it does, that's a much more expensive fix for all involved versus finding your errors during your development process. So to find errors early. To provide some documentation. So this one is, you have to be a little bit intentional on this one. So just creating tests doesn't necessarily give you much more documentation, but if you're intentional with some of the things that we're going to talk about, you start to realize that your tests are actually documenting some of the functionality and business rules that are actually part of your code base. So we'll see some of that. And then help facilitate better software design via refactoring. So as I said before, when you, let's say, go back to or return to a code base and you want to refactor code based upon something that you either learned or somebody pointed out, having, I guess, a test suite will actually help with that. In addition to it, part of unit testing is that your code has to be testable in some way, right? So some of the more, I guess, efficient software design techniques and better techniques force your code, at least when you're trying to achieve testability, force your code to have a better software design. So style. So there are a couple styles. The first style is output verification. And let's dig into that a little bit. So you want to provide your system under test with known inputs and test for expected outputs, so output verification. In my opinion, this is probably the highest value when you think about it. Because the moment something, let's say it's a calculation, the moment it goes awry, you actually know immediately that there's an issue. Also, it tends to be fairly isolated if you're designing your test very well. But it definitely does have the highest value compared to some of the other options. So our next option is state verification. And in this scenario, what we're doing is we're providing our set with known inputs and our public, or use the public interface and test the state, single or multiple data points for expected values. So this has, it definitely has high value. But it does have a tendency to be susceptible to some side effects. So we have to be a little bit more careful with that. But we definitely don't rule it out. And there's some examples of that in the code we're going to take a look at. And then collaboration verification. So this one, what we do is provide known inputs, or we use a public interface to the system under test. And basically, we test how it interacts with its collaborators. This one has the least value, and we'll explain why in a minute, compared to the other two verifications. But it definitely offers some value. And one of the cons with this is that it's typically pretty brittle and difficult to maintain. And I have further explanation as to why that is shortly. So what defines a valuable test? Well, it has a high chance of catching a regression bug, which is one of the key things that we're after. It has a low chance of producing a false positive. And it provides feedback, or fast feedback. So when we're looking at the value of our test, these are the types of things that we're looking for. So now what can cause a test to lose value? Well, test names that do not effectively describe the test. That is a huge contributor to tests losing values. Complicated unit test code. Remember, this is code testing code. We want to keep things as simple as possible. testing more than a single unit of work. So this can lead you to a number of problems. One, if we're looking for feedback and we're looking for feedback fast, if we have the opportunity to actually have multiple results that we actually have to go and research and figure things out, it kind of impedes your speed in terms of determining what actually is broken if you have a failing test. So we definitely do not want to test more than a single unit of work. And then, of course, if your tests are brittle to set changes. So if I have to, every time I make code changes, I actually have to do a lot of maintenance on my tests. That's just a lot of extra work that we should try to avoid. So those tests aren't as valuable because of the maintenance costs. And of course, it leads into difficult to maintain. We definitely don't want that extra work. Unreliable. This one's a key one as well. So especially if you're working with a team of individuals and they're running a suite of tests that they may not have written. Well, if we're getting a lot of false positives, your team's actually going to lose a lot of confidence in the test and actually won't even bother. So this is actually a critical one. And then slow. We're not patient. So if your tests are running an extremely long time, no one's really going to wait around for the results, and even if they look at the results, it's actually going to be a stretch. So they will lose value in being slow as well. So how do we make our unit tests more effective and valuable? Well, we start by making them clear, simple, and readable. And let's dig into that a little bit. High value is another, and then flexibility. So clear, simple, and readable. First of all, we should make our test names consistent and meaningful. Utilize a naming convention. It's pretty simple, right? For example, a three-part naming convention is what I try to subscribe to. And here's an example. The first part of the name is a unit of work. The second part of the name is the initial condition. And the third part of the name is the expected result. So an example using that naming convention could be something as simple as, let's say in our software, we're totaling an invoice. So the unit of work is total invoice. And the initial condition should be, or could be, we have a valid invoice item, or a valid series of invoice items. And the expected result is some number, okay? Another example would be, let's say our business rules indicate, now this is not a real world scenario, but it could be part of some system, that we're totaling an invoice and we have a invoice item that's of negative value. And when we encounter that, we should throw an exception. So initial unit of work would be total invoice. Initial condition would be invalid line item, and expected result would be throw an exception. So why is that important? Well, it's easy to scan and search for. So if you have thousands of tests, you can actually zero in on exactly what's going on using that naming convention. For some systems, if you're looking at them from the user interface, typically it's sorted by maybe method name or test name. Then what happens automatically is that the tests are grouped together by the same unit of work. So automatically you're getting test segmentation by units of work that you're actually testing. And then it also provides some insight into the business rules. So if we go back to the example where I indicated total your invoice and invalid line item as initial condition, and expected result is throw an exception, that actually, when you actually read that, you can understand exactly that's part of at least part of my business rules, at least one part of my business rules. So that actually helps out. That adds a lot of value to your suite of tests, particularly when you're dealing with thousands. Keeping with clear, simple, and readable, test suites should be organized. And some of what we just talked about helps with the organization. Don't repeat yourself. Obviously, what we're applying to our normal development definitely should be applied to our unit tests. It's code. Descriptive and meaningful names. So we talked about a naming convention. that the name was very descriptive and very meaningful. A person that's somewhat familiar with what's going on in your system or your application, and looking at the code could actually understand what's happening there. Follow a distinct pattern in your test. So first section of your test should be sort of a setup and arrange section, and we'll see examples of this and when we look at some code. Then you take action as the next section, and then we assert. We're looking for the result or condition, and we'll walk through that in some of the tests that we have examples for here. Focus on high precision. Test one expectation per test. So if you're looking for multiple expectations in one test, then that sort of leads you to a scenario where the test is not really pointing you right where the problem is. And so as a developer, you have to spend more time trying to figure out exactly what's broken. So that focus on high precision. If you end up with multiple expectations, then obviously the value of that test actually declines. Multiple assertions on an object is okay, but be careful. So if you are, here's an example where it is okay. So let's say you're doing state verification. That's a test style, and you're calling either you're sending in some inputs or you are calling a method on a public interface, and there's a certain state that object should have that you need to check maybe multiple properties of that object. Then that's okay. But when you start getting in scenarios where you have multiple assertions on like multiple objects, then you start to get into situations where it's a little gray in terms of what's going on there, what exactly is wrong, and that's where you kind of lose precision on your test. Tests should point to precise location of the problem, right? We don't want to have to go searching for, okay, this test failed now we have to spend hours trying to figure out what caused it to fail. It should take you right there. So high value. Well, we want to focus on testable code. Use dependency injection to provide your dependencies. Avoid using new. So it your normal code, it creates dependencies. And then avoid global state. So global state, it definitely has a purpose. But in some systems, if that global state can be modified by various actions within the system, then all of a sudden, if your unit tests are actually testing global state, they're not as reliable as they can be because it's not isolated. So you can deal with side effects. Be careful with static methods. So scenario that actually I'm very familiar with on a code base that I work on. It was originally written some time ago, and there's heavy use of statics in this code base. And in order for us to make the code testable, in certain scenarios, almost the entire environment has to actually be stood up so that those values are available. And so it makes it extremely difficult to actually write unit tests on certain parts of our code. So just be careful. I mean, they have their purpose, but think about testing when you're using statics. Focus on testable code. Use seams with legacy code. So here's an example. Let's say you have code that has a new dependency, or it's instantiating an object during its execution or existence. Go ahead and continue to do that, but provide the ability to override it. And then use that ability to actually test it. So that's one way of using seams with legacy code. Favor composition over inheritance. So this is where dependency injection can be your friend as well. So instead of having this huge inheritance hierarchy between your classes, compose functionality by using independent classes and actually using dependency injection to provide those dependencies. What this does for you, it allows you to zero in on those components and be able to test them independently of the other components. Now, you might want to have some additional testing involved in when those components come together, but at least you can isolate them individually and test them individually. And then finally, apply solid principles. I won't dig into a lot of what solid principles are, but basically, mean, you can search, but I mean, we can talk all day. Actually, probably talk a week on solid principles. But when you apply those to your code base or your code, testability is something that is a beneficial outcome. Test code that has high risk. So when you have systems that have complex workflows, calculations, you definitely want to spend your time creating your unit tests there. One thing to guard against, though, is to minimize the what-if scenarios. So we can get into the cycle where we are, what if this, what if that, what if this, and you can kind of just keep going and going and going. Well, at some point, there's a diminishing return on that effort. So we want to be very careful that we don't go down any rabbit holes as it relates to the what-if scenarios, but definitely consider them. Make sure you cover all your business rules. That's the reason why your code base or your application was written, to satisfy some business need, and it has business rules. So make sure that you at least, from a unit testing perspective, make sure all of those are covered. Cover the happy paths and the non-happy paths. The happy paths are fairly easy, but think out of the box. The what-if scenarios. What if certain values that you expect, a certain range of values that you expect, are not available but are input into your system under test? You want to look for things like that and make sure you test those. So in my previous example, total invoice, we had unexpected or invalid line items. We definitely want to test for that. All right, here's another good one. Avoid testing things the compiler would catch, so types. So for example, if you have a method that returns a certain type, it's kind of redundant in your test to have an assert on the type of, right? If it's going to return a string, and you return something different or try to return something different, the compiler is going to catch that. So you definitely want to avoid testing those types of things, just because it's going to lead to more maintenance of tests and things like that, and value-wise, you're really not getting much out of it. There's one scenario where you might want to look at that. Let's say you have a method that returns a generic object, so it's not really strongly typed. Then you might want to get into those scenarios. But for the most part, I'd like to think that a lot of the times when we can have a strongly typed scenario, that's what we go for. And so duplication of testing for types is just not a value. And the same thing for text. So if your system is not reliant upon, let's just say magic strings, where the strings actually cause your applications to take either different paths or make decisions on strings, things like that, then there's not a lot of value with unit testing for a certain string. That there's not value there. And then the risks are minimal as well, as long as your code's not dependent upon a specific string or specific text. Flexible. So, and again, these are guidelines, so these are not hard and fast rules. So maximum of 1 mock per test. That's what I try to go after. It may not work in your scenario, but it's a worthy goal. Fewer than 10% of your overall test with mocks. Now this might not work for you as well, and it's not that mocking is a bad thing, but what it does is it introduces a lot of complexity to your code, and it also or to your test, and it also introduces a level of dependency in a sense that if something changes on what you're mocking, then there's some maintenance issues that you might have to deal with in your test. So try to keep those as a minimum. Again, that's a guideline, not a rule. Do not test private methods. It's pretty obvious. Private methods are generally used by public methods that are part of the interface, and so those methods should be covered by testing the public methods. Try to test scenarios rather than methods. So it's not that anything's wrong with methods, but when in terms of flexibility, when you're considering that, typically if you design in your system a scenario or a certain workflow, if you test at that level, generally those don't change much as your system matures. So the end result is that you can make a lot of changes or underlying changes that are part of that process and not actually impact your test. Versus if you had a lot of tests that were focused on the underlying parts of that workflow, and then you're making changes, then you're more susceptible to having to do maintenance on a lot of unit tests. So if you can, try to hoist your test up to the scenario workflow level rather than individual methods, and that's just for flexibility. All right, so I'm going to switch to some code to give you some examples of kind of what we got going on here. So give me just a second. We'll go back to this resource slide. Okay, hopefully you guys can see the code. So this is not to get into a lot of details. I mean, this is a Xamarin mobile app that I use a lot for a lot of talks, and it's a simple app. It's just a to-do app, but it has some testing built into it as part of the overall project, and it demonstrates some of the things that we've talked about at this point. So let's take a quick look. Just for context, here's a to-do item. This class, it represents the to-do item in the system. And one thing I just wanted to point out, that when it's instantiated, what happens is we actually create a GUID and we set it to one of the properties. So that's the first thing that happens. All right, so how do we test some of this? Well, the first thing, since the way this project is set up, this to-do item test class is basically the domain, at least one of the domain objects of the entire system that we are actually modeling here. And the way this is set up, it's actually adhering, or at least attempting to adhere to the onion architecture, where you have your domain classes that are at the center of everything else that's going on, and they're independent of everything. So there's no dependency. So that makes this class very easily tested. So let's take a look at the tests that are associated with it. So here's an example. So I want to point out a couple things here. If you look at the name of the test, it follows the naming convention that we used earlier. So the unit of work that we're testing is create new to-do item. And the initial condition is a new to-do item. And what we're looking for, the expected result is the ID is a string, okay? Now, this works well. This test runs, it news up a to-do item, and then what I'm doing here is I'm asserting on the instance of type ID being type of string. Now, it works well. But if we look at the class, that property is a string. So it's strongly typed. It's not, I mean, I can't assign it anything else, right, unless it's a string, right? And then in this method, I generate a new GUID, and I cast it to a string and assign it, right? So even though this works, and it's a decent test, we can do better, basically. All right, so what's a better test look like in this scenario? Well, here's a better test. Instead of duplicating the effort of testing on type, which the compiler is going to catch anyway, why not assert if it's null or not null, and then assert that it has a length of greater than 0. So you can see how that type of test is actually a little bit more meaningful in the sense that testing the type, or at least duplicating the testing of the type that the compiler is going to implement. So that's what I was referring to earlier, to not write tests that the compiler is going to catch during compile time. So let's take a look at a few other tests that we have set up here. So this app has, it uses basically a design pattern called MVVM. So there's a concept of view models, and I won't go into all the details there, but the way the app works, when you run, you get a list of your to-do items from a database, actually that's synced with Azure. And so what we want to test here is on that first screen, or at least that first interaction with the database, that if I'm asking for a list of tasks from the database, that I'm going to have some result. Okay. Now, what I've done is I didn't want to create an integration test, so I don't want to rely on actually talking to the database or talking to Azure to sync up my items. So here's a good example where you would use a mock. Now, I'm not using a mocking framework in this scenario. I'm actually creating one on the fly. So if we take a look at the mock of the database, it is actually implementing an interface, and the interface is the same as the interface that I'm actually using as part of the normal application code. So I have to obviously reproduce and adhere to that contract. The first thing that this guy does when it's actually instantiated is it calls this method called Initialize Database. And for the mock, what it does is it adds a to-do item, and it stores it in the database, and that's all it has. So there's one item in the database, and I know it's there because of how the class is constructed. So what I can do is I can say, okay, well, my view model is responsible for actually accessing, or at least using the database to actually retrieve the list of items. So I can actually test that with a mock that actually implements the same interface. So what you see here is a test that uses the same naming convention, and it starts by saying retrieve list of tasks from database. That's that's basically the unit of work I'm testing. Now in this scenario, the initial condition is that there's one task in the database. And then my expected result is I'm going to get a list with one task. So in my setup area, what you see here is I'm actually newing up a list task page view model. And I am, since it's actually set up to use dependency injection, I can actually send in my mock database instead of the actual database that would be running when the app's running live. So now that view model is available. And now, and assuming that I have some knowledge of the mock, that there's one item in the database when I new up the mock, I can actually call the same method that's called on the view model to actually load the items, which is the action in line 16. So I have a result. I get back a record count as part of that, as a return value of that method. And the last part of my test is I'm asserting that the record count is 1. Now there's some key things here that I want to point out besides the obvious things that I just walked through. This test is very, very reliable because the condition, or at least the state of the mock database is known. I'm calling the same, or at least the test is calling the same methods that would be called on the view model in the actual running system. So as far as I'm concerned, from a test perspective, I've isolated this view model to a point where I can actually test loading items in a reliable way. Now imagine trying to write a test where I was actually trying to attempt to do this, and I was actually going to the database. Then I would have to actually have code, maybe some startup code that clears the database, actually adds one, verify that there's one, then actually run this test. So now all of a sudden I've entered a bunch of complexity in the scenario where in this case here, everything is basically in memory, and it's a true execution of what the app would execute when it's running. So does that make sense? All right. So so this is a very durable test. If by chance I changed, maybe I refactored load items async and I caused something else to happen where this is not reliable anymore, when this test runs, then I should get a failure, a reliable failure, not a false positive. Okay, so let's take a look at one other set of tests that we have in this sample app. So as explained earlier, the app, when it runs, you get a list of to-do items. Well, if you drill into a to-do item, you can actually look at the details. So we're going to take a look at looking at the details. And what we have in the details is we have this view model called create page view model, which actually is dual purpose. It can actually display, or at least facilitate the display of an existing one, or actually create a new one. So let's take a look at the first test here. It's a little wordy, I will say that, which is actually an indicator of something else that's a problem in my application. So I'm going to attempt to read it. So it's add to-do item to database and retrieve to-do item from database. That's my unit of work. My initial condition is new to-do item. And then my expected condition is that the new to-do item that I started with and the view model's to-do item has the same properties. Okay, so that's a lot, right? So you see what happens is that actually I new up a to-do item. So here's my setup from 15 to 23. That's my setup. So I have a new to-do item, give it its values. I set up a new data store. It's a mock. And then I new up my create page view model. So once again, I'm using dependency injection in this application. So I can new up a create page view model and actually provide mocks of the underlying data types and actually can test it in an isolated fashion. So in this case, it's a to-do item and a data store. So I'm sending that in. So now I have the same view model that my application will be running during runtime. So here's my action section, 25 and 26. I add the to-do item, which will add it to the data store. And then I load the to-do item from the data store, specifying the ID, okay? And then the last 3 lines are basically my search section, right? So what I'm doing, you can see here, is that I'm looking at the to-do item that I created, and I'm comparing the values to what the view model has after it loaded it from the database. So that's my verification. Now, you might say, well, I thought you said not to do a bunch of asserts. Well, that's okay because I'm only dealing with a single object, right? I'm not asserting one object and inserting over here, so I'm not testing like multiple outcomes. The fact of the matter is I want to load one from the database. I want to take a known item, add it to the database, load it back, and make sure I have the same value. So that's what I'm trying to accomplish. And that's what happens here. Now, point out, so there's some design issues here that the test, because of the name, is actually uncovering for me. Well, it's a little convoluted right now because what happens is when I add a to-do item, the view model has no knowledge of this at this point what it just added. So it adds it and kind of moves on. So I have to do this sort of 2-step process. Now, for me, less code for me and the less steps that need to happen is a better situation. Your business rules might require that to be that way. But it's sort of a smell when you see all of this in a name, that just to do a simple test that I'm able to successfully add an item to the database. So I'm not going to fix it here, but that's just something to look at when you get these long names. Maybe there's something wrong with my design, or not wrong, but something that can be improved. I won't use absolute wrong because there's 50 million ways of solving these problems. All right, and let's take a quick look at another test. This one's a little simpler, but it follows most of what we talked about. Add to-do item to database and delete to-do item from database. That's my unit of work. New to-do item is the initial condition, and deleted to-do item is the expected outcome. So very similar. I have a setup section, lines 33 through 41. I just new up an item, a to-do item, and I again use my mock database. I'm testing the same view model, but I'm testing a different action. The first one was add, now this is delete. And then in my action section, I actually call the add to do item. And then I immediately, once it returns, I call the delete to do item. Now, and then I assert that the result is true. Okay, so the way the view model works, and you can't, this is another, I'm not going to say wrong thing, but it's something that you might, as a software developer, might want to look into, is that you kind of have to know what's happening on the view model here. So you can kind of glean that, hey, when I add a to-do item, and then I immediately go and I can go and delete it, and I'm not passing any parameters, that the new to-do item, the state of it when it was added is still part of the view model. So it's not being cleared. So that's why I can immediately just call delete without actually passing in maybe an ID or something along those lines. That can be a wrong or right thing. It just depends on your business rules. But you can see this has a lot of value. Actually, both of these have a lot of value because I'm not actually going out to the database. So it's not an integration test. It's extremely fast because it's all in memory, and it's going to give me quick feedback if I were to change how any of these methods or either one of these methods works, and if it breaks something, I should see it immediately. Okay. All right, so those are a few examples of some of the principles and some of the ideas that I've shared in the slides. So just a couple of remaining things, and then we can get to some questions. Awesome. All right, so if you want to play around with the code, it's in GitHub. Just look at my GitHub, and there's a specific branch out there that I have set aside for a lot of the testability stuff. So if you go to the testability branch, you can check it out. There's a couple of unit testing resources that I'd like to refer you to. It's a great blog post, how to write testable code and why it matters. You want to definitely check that one out. I'm a Pluralsight fan, so there's numerous videos out there for unit testing, and these are three that I find highly valuable. If you're working with legacy code, here's a couple book references. Working Effectively with Legacy Code by Michael Feathers, and Beyond Legacy Code with David Bernstein. And then for testing frameworks, in this example, I was using MS Test, and there's a great link in the Microsoft Docs for unit testing in C# with MS Test and .NET Core. That's a great one. And then, of course, there's InUnit and XUnit as other unit or testing frameworks that you can use in a .NET scenario. Again, if there are questions, please post them in the Slack channel, the green Slack channel. So I'd like to open it up for questions, and I guess we'll get some out of the Slack channel as well. So any questions in here? Yes, sir. Right. Mm-hmm. So the question is around designing tests, I guess, basically, or at least asking for advice about designing tests so that they are more easily maintained versus going after like code coverage or as sort of your metric. Code coverage is fine. I think it's one of many metrics that you might want to take a look at. But code coverage is not, when I look at it from a value perspective, code coverage is only a part of the equation, right? If you have 100% code coverage, but your tests are unreliable, they're slow, or they give you false positives, there's not a lot of value in that, right? So that's why I believe that it's if you you approach it from more, okay, what's the value that I'm getting out of my test? What do I need my test to do? Not just cover this one scenario that could be 1 in a million. My everyday, my business critical functions and calculations in my software. That's what I try to go after. There's nothing definitely wrong with code coverage, but I think personally there's more to it than just code coverage. You're welcome. Any other questions in here? Okay.
Do you want to just read them?
Yeah, sure, I can read them. All right, so, okay, the first question in the Slack chat is, how do you go about picking your testable unit? Recognizing the fact that if your unit test is too low of a level, you risk testing the implementation incredibly brittle. But if you test at a too high level, you bleed into integration. What are some tips to go about deciding on your testable unit? So that's a great question. So you know, I guess it revolves around balance, like I said before. If you find yourself, and some of this stuff will kind of come out in discovery as you're actually using your testing suite. You might go after testing every method individually, and then you find yourself going into a scenario where your maintenance becomes a nightmare. And then at that point, what you might want to do is take a look at the tests that are actually causing that issue, see if they're related or part of a larger process, right? And then hoist your testing to at least that level. Now you're testing, not necessarily doing integration testing, going out to different systems, but you're at least testing a business process. Now, typically business processes kind of fall into a more static arena, right, where your app's written for a certain process or a certain problem, and that doesn't change much. So now you're less susceptible to having to maintain that. So that would be my approach. I mean, go low, and then over time, as you learn how your system's evolving, then start to move to a higher level in terms of your testing. Let's see. The next question is, how do you feel about using randomness in testing? Using random numbers that will still be valid instead of hard coding integers to pass in. Okay, so yeah, that's a good question. I mean, randomness is a pretty difficult thing to test, obviously. So if you're at let's say your style is output verification, but your input's random, that's going to be pretty difficult to try to isolate or at least have a valid result that you can, or at least a reliable result that you can test in that scenario. What I would probably do is maybe test state as part of it. Maybe an example might be, hey, if I get a random number between a certain range, then my system under test should have a certain state. Then I would test from that perspective. But definitely from a output verification, the randomness would be pretty tough. Let's see. The next question: are you against using a mocking framework, or did you just make manual mocking class from making sure the presentation was simple? Good question. I am not against mocking frameworks. Actually, I use them. I definitely wanted to keep this as simple as possible. So that's exactly your line of thinking. I did not want to introduce that. Let's see. I believe that is the last question in Slack. So are there any other questions? Awesome. I appreciate your time. Thank you very much. Oh, thank you.